Welcome, roller coaster engineers. Today we are going to work with the Gizmo roller coaster physics. Your objective today is to use the Gizmo to explain the variables of motion as the car travels, including potential, kinetic, and total energies, by manipulating the heights of each hill along with the mass of the car and the friction on the track. Let's start by copying the data table that you see on the screen into your science notebook. Make sure you leave space to record data as we go through the Gizmo. All right, I have set up the first round or the first trial for 35-grammed car. The first hill will be 70 centimeters, the second hill will be 50 centimeters, and the third hill will be 30 centimeters. I will keep the coefficient of friction at 0. As you play with the simulation, go ahead and enter your data into the data table. Continue to do this for 50 grams and 100 grams. The next one I will show you briefly. For 50 grams, I set the first hill to be 90 centimeters, the second hill to be 60 centimeters, and the third hill to be 50 centimeters. Once again, with a coefficient of friction of 0, I played the Gizmo. The results are shown above. I entered the data into my data table. Finally, I completed the last 100-gram car. The first hill I set to 100 centimeters, second hill to 40 centimeters, and third hill to 70 centimeters. And I kept the coefficient of friction at 0. The results are shown above. I also entered that data into my data table. As you can see here, 35 grams touched the egg but did not break it. 50 grams touched the egg and did not break it. 100 grams broke the egg at the end. So what can you conclude about the data that you collected today? Well, here are a few pieces of information that I concluded with my set of data. The first thing is friction. My control variable was set to 0 for the coefficient of friction, which means that nothing causes the car to slow down except for the transfer of potential energy to kinetic energy. I also concluded that the height of hill 2 and 3, the higher the hills are after hill 1, determines if the car will break the egg, due to the amount of kinetic energy left as it reaches the top of the third hill. Mass is also a factor. More mass means greater potential and kinetic energy. The final conclusions that I made were potential energy is stored energy at the crest of each hill, and kinetic energy is the motion energy at the trough of each hill. In summary, mechanical energy is the energy due to the motion, kinetic, and position, potential, of an object. When objects are set in motion or are in a position where they can be set in motion, they have mechanical energy. The car starts at the top of the first hill with the greatest potential energy. Potential energy is dissipated into kinetic energy quickly. This transfer allows the car to reach its highest kinetic energy. This kinetic energy will keep the car rolling throughout the rest of the coaster track. I hope you had just as much luck as I did with this Gizmo. Let's keep building.